Good morning, students. Now this is the last class for the theoretical section. In the last class we have completed that is nothing but the spectral series. We have studied the minimum wavelength and maximum wavelength. Then after that we come across energy level diagram. Simplest thing. Energy level diagram. The diagram which represents the total energy of the stationary orbit of an atom. A diagram which represents the total energy of the stationary orbit of an atom, where the electron possesses the lowest energy in the orbit. The lowest energy orbit is called ground state or normal state. The higher energy states are called excited states. The ground state or normal state is nothing but lowest energy states. Then higher energy states are nothing but what? Excited states. The electrons which possesses the total energy in the respective stationary orbit is represented by horizontal lines. In the energy level diagram, the total energy possessed by the stationary orbit is represented by horizontal lines. The electrons which jumps from higher energy to the respective energy levels are represented by vertical lines. Hence, the energy level diagram consisting of horizontal lines and vertical lines. The horizontal lines represents the total energy of the electron in the respective orbits of an atom, and the electrons which jumps from higher energy state to the lower energy state is represented by vertical lines. Hence, in the energy level diagram, it consists of the two lines, the horizontal lines and vertical lines. So, we know that the nth orbital energy is given by minus 13.6 divided by n square in electron volt. Then I want to calculate the respective energy of the total energy of the orbit, stationary orbit. What is the first orbital energy? What is the second orbital energy? What is the third orbital energy? What is the fourth orbital energy? What is the fifth orbital energy? Then we go for n number of orbits, that is last orbit I take n equals to infinity. For n equals to infinity, that energy in the infinite level is 0. So, I take the total energy of the stationary orbits, that is represented by horizontal lines. This is nothing but E1 is equals to ground state minus 13.6 electron volt. If I keep n equals to 1, what happens? Minus 13.6 divided by 1 square. That is first orbital energy. Then I go for second orbital energy state. N equals to 2. So E2 is equals to minus 13.6 divided by 2 square 4. That is nothing but minus 3.4 electron volt. This is n equals to 1. Lowest energy state, ground state. N equals to 2. Then I go for third orbital state, energy, n equals to 3. So minus 13.6 divided by 3 square 9. So E3 is equals to minus 1.51 electron volt. Then I go for n equals to 3. So n equals to 1, 2, 3. This is n equals to 4. Minus 13.6 divided by 4 square 16. This is E4 is equals to minus 0.85 electron volt. Then I go for fifth energy state, n equals to 5. Minus 13.6 divided by 5 square 25. This is E5 is equals to minus 0.54 electron volt. You do the calculation. Then n number, this is n equals to 6. Last one, I go for n equals to infinity. n equals to infinity. This is n equals to infinity. Infinity is equals to 0. 5 ही क्यों लेना, मिनिमम 5 ले लो, एक एक्स्ट्रा ले लो, बाद में n equals to, जितना ज़्यादा लोगे that is complication for you to draw the energy level diagram. So what is the hint? So Enth equals to minus 13.6 divided by n square electron volt. So the horizontal line represents the total energy of the stationary orbits in an atom, and the electron jumps from higher orbit to lower orbit, that is nothing but represented by vertical lines. If the electron jumps from higher orbit to the first orbits, higher orbit to the first orbit, any higher orbit to the first orbit, any higher orbit to the first orbit, when the electron jumps from any higher orbit to the first orbit, it gives the Lyman series. It gives Lyman series. देखो, any higher orbit to the first orbit, any higher orbit to the first orbit, 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 higher orbit to the first orbit. This gives Lyman series. The electron jumping from higher orbit to the respect to lower orbits, that represents the vertical lines. If they jumps from any higher orbit to the first orbit, then it gives what? Lyman series. If the electron jumps from any higher orbit to the second orbit, that gives Bohrs series. देख लो, easily draw कर सकते आप लोग. This is nothing but Bohrs series. If the electron jumps from any higher orbit to the third orbit, any higher orbit to the third orbit, this gives Paschen series. Again, if the electron jumps from any higher orbit to the fourth orbit, Lyman series, Bohrs series, Paschen series, bracket series. This is bracket series. If the electron jumps from any higher orbit to the fourth orbit, third हो गया, this must be fourth, इसको fourth ले लो, third हो गया. Now this is nothing but fourth होना है, third को लेके आए. Any higher orbit to the fourth, this is nothing but bracket series. If the electron jumps from any higher orbit to the fifth orbit, that is nothing but Fund series. बीच में रहते हैं. अब जितना ज़्यादा लाइन लेंगे हॉरिजॉन्टल लाइन, फिगर फर्स्ट फिगर तो कॉम्प्लिकेशन होगा. मिनिमम एक तो लाइन चाहिए, यहाँ पे इन्फिनिटी टू फिफ्थ, एक तो लाइन रिप्रेजेंट एटलीस्ट 2 लाइन्स. अब बीच में डाल सकते हैं डैश डैश बोल के. So it means that from the energy level diagram it is clear that so horizontal line represents the total energy of the electron in the respective stationary orbits. So if the electron jumps from any higher orbit to the respective lower orbits, that is represented by vertical lines. If the electron jumps from any higher orbit to the first orbit, that gives the Lyman series. Any higher orbit to the second orbit, Bohrs series. Any higher orbit to the third orbit, Paschen series. Any higher orbit to the fourth orbit, that is bracket series. Any higher orbit to the fifth orbit, that is Fund series. Now this is nothing but energy level diagram. Simplest one. एक बार पूरा देख लो. The horizontal represents the total energy of the electron. ये कैसे आ गए? We have got the total energy of the electron in the nth orbit minus 13.6 divided by n square electron volt. एक बार फिगर को glance कर लो. Then I go for some important definition, that is ionization energy, ionization potential, excitation energy and excitation potential. देख लो. फिगर को देख लो, इजी आराम से ड्रॉ कर सकते, कोई प्रॉब्लम नहीं है. सही है? Is it clear? Right. थोड़ा डायग्राम डालते हो तो थोड़ा केयरफुली डालो. Shall I go for the next? Yes. Then after this we come across some important definitions. निकाल दो. I go for some important definitions. There are the two terms, one is excitation, another one is ionization. One is excitation, another one is ionization. So from these two terms we have got the two more definition arises, excitation energy and excitation potential, ionization energy and ionization potential. Then what is that excitation? Then what is the ionization? Excitation means shifting of the electron from one orbit to another orbit. The electrons in the atom, but electron is going to be shifted from one orbit to the another orbit. The process of this shifting is called excitation. If you want to remove the electron completely from the orbit, from the atom, and that process is called ionization. Complete removal of the electron from the orbit to the atom totally, and that process is called ionization. The electron is in the atom, but it is shifted from one orbit to the other orbit. That process is called excitation. Then what is that excitation? Energy. The amount of energy required to shift the electron from one orbit to the another orbit is known as excitation. From lower orbit to the higher orbit, whatever the amount of energy is required for the electron to be shifted, and that energy is called excitation energy. And this excitation energy is measured in terms of electron volt. The excitation energy is measured in terms of electron volt. क्यों इलेक्ट्रॉन वोल्ट करते? We know that V equals to W by Q. W equals to V into Q. V into Q. Charge electron is nothing but Q equals to N equals to 1. E electron volt. Work is measured in terms of joules. Electron volt is also the unit of what? The work. The minimum amount of that is the amount of energy required to shift the electron from one orbit to another orbit in the atom is known as excitation energy. The excitation energy is measured in terms of what? The electron volt. Then what is that excitation potential? So the minimum acceleration potential. So when you come across what? The excitation energy concept, then we come across the excitation potential. The excitation potential is nothing but, so we are going to be the minimum acceleration potential, the minimum acceleration potential required or provided to the electron to jump from one orbit to another orbit. The minimum acceleration potential provided to the electron to make the electron to be jump from one orbit to another orbit is known as excitation potential. Now this excitation potential is measured in terms of volt. The minimum acceleration potential provided to the electron to shift from one orbit to another orbit is known as excitation potential. This excitation potential is measured in terms of what? Volt. So the excitation energy, excitation energy in electron volt is equals to excitation potential in volt If you have calculated the excitation energy in electron volt, that same value is written in terms of volt that represent was excitation potential. The minimum acceleration potential which is provided for the electron to shift from one orbit to another orbit is called excitation potential. That excitation potential is measured in terms of volt. So we have calculated the excitation energy that is in terms of electron volt, that is represented in terms of volt, that gives excitation potential. Same concept है ionization में, right? From one orbit to another orbit बोलते हैं, completely removing from the orbit एक term use कर लो, that is nothing but what? Ionization concept. Then I come across ionization. Ionization is the process of removing of the electron completely from the atom. The amount of energy required to remove the electron completely from the atom is known as ionization energy. The amount of energy provided for an electron to completely remove from the atom is known as ionization energy, and this ionization energy is measured in terms of electron volt. The minimum accelerating potential provided to an electron to remove completely from an atom is known as ionization potential. कुछ भी नहीं है, खाली एक टर्म चेंज करना है. One orbit to another orbit आ गया, that is nothing but excitation. Complete removal of the electron from the orbit. Whatever the minimum amount of potential, accelerating potential provided to an electron to remove an electron completely from an orbit, that gives the ionization potential. Once again, ionization energy in electron volt is equals to ionization potential in electron volt, in volt. Ionization energy in electron volt is equals to ionization potential in volt. Potential is measured in terms of volt, energy is measured in terms of electron volt. Ionization energy in electron volt is equals to ionization potential in volt. Now these are some important basic concept for excitation and ionization. Is it clear? Excitation means the removal of the electron from one orbit to another orbit. Whatever the amount of energy is provided for that is called excitation energy. The minimum accelerating potential provides an electron to shift from one orbit to another orbit is nothing but excitation potential. Excitation energy in electron volt is equals to excitation potential in volt. Similarly, the removal of the electron completely from an atom, and that process is called ionization. The amount of energy provided for an electron to completely remove from the orbit is known as ionization energy. That ionization energy is measured in terms of electron volt. Then the minimum accelerating potential which is provided for an electron to remove completely from an atom, and that is known as ionization potential. Ionization energy in electron volt is equals to ionization potential in volt. Now this is our basic concept. For hydrogen atom, for ground state, the ionization energy is plus 13.6 electron volt. The ground state energy is nothing but minus 13.6 electron volt. If you want to be ionized, completely remove the electron from the orbit. That is for hydrogen, it is plus 13.6 electron volt energy. Right? Then, what are the merits and demerits of Bohr's atomic theory? Then we come across merits and demerits of Bohr's atomic model. Merits and demerits of Bohr's atom model. Bohr's atom model. Because of having the maximum merits, still we are going to be following the Bohr's atom model. There is a certain demerits, and those demerits are going to be rectified by using vector atom model. Still today we are going to be accepted Bohr's atom model because of what? Maximum merits. Then what are the merits of Bohr's atom model? So, first time the atomic model concept, the atomic model is proposed by the scientist Niels Bohr. The complete atomic model is first time it is given by the scientist Bohr. Hence, we are going to be following the Bohr's atomic model. The size of the atom is provided by Niels Bohr. The first time the size of the atom, that is 10 to the power of minus 10 meter. Then we come across the size of the nucleus 10 to the power of minus 15 meter. All these concepts are obtained by the Niels Bohr. Now the Niels Bohr is done, what he has done, he takes the Rutherford's atomic model and again he has applied the Planck's quantum theory. By merging these two factors, he has proposed a new theory, that is nothing but what? Bohr's atom model. The Bohr's atom model provided the Rydberg constant R equals to in terms of mass of the electron, charge of the electron, epsilon naught is constant, velocity of the photon c, then Planck's constant h. Now first time the Rydberg constant is provided in terms of the constant values. M for hydrogen atom Z equals to 1, M, E, epsilon naught, C and H. For hydrogen, whatever by substituting the value Z equals to 1 and all the constant, the value of R is going to be calculated 1.097 into 10 to the power of 7 per meter. This is excellent agreement with what? Theoretical value and practical value. Whatever the value is obtained, that Rydberg constant, that is nothing but R equals 1.097 into 10 to the power of 7 per meter. This value is exactly accepted with what? Theoretical value and experimental value. एक बार पूरे values को देख लो. R का value important है. That is nothing but sometimes it is asking the R value in the theoretical section. वो देख लो. Right? एक बार पूरा R वो important value. What is the value for R बोल के? Right? देख लो. By substituting all the values of constant for hydrogen atom Z equals to 1, mass of the electron, charge of the electron, epsilon value, C value and H value. The R value is 1.097 into 10 to the power 7 per meter. This value is excellent agreement with what? Theoretical value and experimental value. एक बार देख लो, equation को देख लो. Right? Then after that, he has provided the angular momentum mvr is equals to an integral multiple of h of h divided by 2 pi. Now this concept is on the basis of what? Bohr's atomic model. The angular momentum concept of an electron which are revolving around the nucleus is provided with the help of Bohr's atomic model. That is nothing but Bohr's quantization rule for angular momentum and an integral multiple of h divided by 2 pi, both are equal. That Bohr's quantization rule is completely provided with on the base of what? Bohr's atomic model. Now these are the important merits. Then what are the demerits? What are the demerits? When you come across the demerit concept, the Bohr's atomic model is applicable for only the atoms like H alpha and H beta for very small elements, that is nothing but H alpha and H beta. Like these kind of the elements are going to be implemented to explain by using what? Bohr's atomic model. The Bohr's atomic model is failed if the atomic number increase Z greater than 1. The atomic number fails, that is Bohr's atom model is fails if the atomic number of the element is Z greater than 1. Next one, the Bohr's atom model explains the spectral line series, that spectral line. He never gives the information regarding the intensity of the spectral lines. The Bohr's atomic model fails to give the detailed information regarding the intensity of the spectral lines. The next point. The Bohr's atom model never gives the explanation of wave nature of the electron. When the electrons are revolving around the nucleus, he never gives the concept of what? Wave nature of the electron. Bohr's atomic model never gives the information regarding the wave concept of what? Electrons. So, when you study the spectral series, the fine line of the spectral series of hydrogen atom is also not explained by the Niels Bohr. Bohr's atomic model is specially meant for the hydrogen atom and hydrogen-like atoms, but he never gives the information, the fine structure of what? The hydrogen atom spectral series. He never gives the information of what? Intensity of the spectral series also. When you take the spectral series and subject it to the magnetic fields, the splitting of the spectral lines into fine lines under the effect of magnetic fields, that is called Zeeman effect. This also not explained by the Niels Bohr. The splitting of the spectral lines under the effect of magnetic field is not explained by the Niels Bohr. Yes. In the demerit, next demerit, the electrons are revolving around the nucleus in a circular orbit. All the electrons are revolving around the nucleus in a circular orbits. There is a possibility of elliptical orbits also. Now, this elliptical orbit concept of the revolution of the electron around the nucleus is not explained by the Niels Bohr. Later on, it is going to be corrected by the vector atom model. There is a possibility of electrons revolving around the nucleus in elliptical orbit also. But he explained only the electrons are revolving around the nucleus in a circular orbit. There must be the possibility of what? The elliptical orbit also. He has not explained the Niels Bohr elliptical orbit concept. The next most important one, the Bohr's atomic model do not explain the arrangement of the electrons in the atom. How the electrons are going to be arranged in the atom in the respective orbits. It is not explained by the Niels Bohr. Now, these are the important demerits of what? The Bohr's atomic model. The next one we come across the stationary orbit concept. Concept of stationary orbit. The Bohr is not unexplained for a long time. Then later on, the de Broglie, who introduced the concept of what? The matter waves or pilot waves, which are associated with the electron. When the electrons are revolving around the nucleus, the standing waves or the stationary waves are associated with the electrons. They are around the orbit. When the electrons are revolving around the nucleus, they are associated with stationary waves, and these stationary waves are around the orbit. When the stationary waves are found around the orbit, when the electrons are revolving around the nucleus, they are associated with the stationary wave. So, the circumference of the electrons around the nucleus, that is 2 pi r, is equals to an integral multiple of wavelength according to de Broglie. When the electrons are revolving around the nucleus, they are associated with the standing waves. The circumference of the electron around the nucleus, that is 2 pi r, is equals to an integral multiple of wavelength. So, when the electron is revolving around the nucleus, for the first orbit, there is the existence of what? One stationary wave, n equals to 1. There is the existence of what? One stationary wave in the first orbit. When the electron is revolving around the nucleus in the second orbit, it consists of 2 stationary waves. 2 stationary waves. Now these are nothing but 2 stationary waves. When the electron is revolving the third orbit, it consists of 3 stationary waves. So, these are the 3 stationary waves. We know that. What is the concept of stationary wave? Now, this is nothing but one stationary wave. One stationary wave consists of 2 half waves. 2 stationary waves consist of 4 half waves. 3 stationary waves consist of 6 half waves. So, the circumference of the electron 2 pi r is equal to an integral multiple of lambda n lambda. But according to the de Broglie's, that is wavelength concept, we know that E equals to mc square, E equals to h nu, that is nu equals to c by lambda. Both are compared. Mc square equals to sc by lambda. Once you get cancels, m into c equals to h by lambda, which implies lambda equals to h by m into c. So if the particle is traveling with the speed of light, then we take the c. For the material particle that travels with the speed of what? Velocity. This is m into c is nothing but momentum. So for material particle, lambda equals to h by p. So that p equals to mass into velocity. Now this is nothing but lambda h by me. That is nothing but de Broglie wavelength, lambda. But lambda equals to, shall I take h by mv? Listen to me, this is my concept. If I substitute, निकाल दे तुम्हें पूरा concept को. If I take the equation 2 pi r n, what is lambda? H by mv. So I make the cross multiplication, I make the systematic arrangement nh divided by 2 pi. Then I can say that angular momentum L equals to mvr is equals to an integral multiple of h divided by 2 pi. So according to the Bohrs quantization rule, an integral that is angular momentum of electron around the nucleus mvr is equals to an integral multiple of h divided by 2 pi. The angular momentum of the electron in a stationary orbit mvr is equals to an integral multiple of h divided by 2 pi. Now this is the concept from the stationary orbit. When the electron is revolving around the nucleus in a stationary orbit, the angular momentum mvr is equals to an integral multiple of h divided by 2 pi. Now this is our basic concept. This is Bohrs quantization rule में यही हम ले लेते. So it is proved from the stationary orbit concept. It is not explained long time by the Niels Bohr. So de Broglie used the concept of stationary orbit. When the electrons are revolving around the nucleus, so he takes the concept of what? The matter waves or pilot waves. When the electrons are revolving around the nucleus, so they are associated with the stationary waves, and these stationary waves are around the orbit. So the circumference of electron 2 pi r in a stationary orbit is equals to an integral multiple of wavelength lambda. Then we take the concept of de Broglie wavelength, lambda equals to h divided by 2 pi m h divided by mv, substitute lambda, then make the systematic arrangement. Final conclusion, the angular momentum of an electron in a stationary orbit is equals to an integral multiple of h divided by 2 pi. Now this is our equation. Now this makes the end of what? Atom. Atom में कुछ भी delete नहीं हुए सो syllabus. This is the only topic. Nothing should be deleted. Right? So already आप लोगों को notes provide करे उस रहते हैं. एक बार वीडियो को देख लो अच्छी तरह से. Then you refer the notes. You can easily understand the topic. कहीं पे भी आप लोगों को बैठ करने की ज़रूरत नहीं है. आप लोगों को hint भी दिए सो है formula कैसे याद रखना बोल के. I hope that you have understood the topic. Is it clear? Yes. So let me continue with the next class. That is nothing but numericals. I do almost all the numericals from the NCERT. I hope that you have understood the topic. Okay, next class we start with numericals. Thank you.